Welcome back to Calculus AB. Today's topic 3.6, calculating higher order derivatives. So the learning objective is determine higher order derivatives of a function. So just as you can obtain a velocity function from differentiating a position function, you can obtain acceleration function by differentiating a velocity function. So again, if you guys remember from before, we have s of t is our position function. If we take the first derivative of that, we find v of t, which would be our velocity function, right, s prime. And if we take the derivative of that, we would find a of t, the first derivative of velocity, or the second derivative of position, which in this case, that would be given to us as acceleration. So now, if you guys notice, in the next ones, we have just a couple of different things. The first derivative is denoted by y prime or f prime. You guys remember that part, right? And then dy dx as always. Now, for the second derivative, we're just going to have two tally marks right there, saying for the y and the f of x. And then when we use the dy dx, make sure you guys look at where the exponent is at. You put a 2, d to the second power y over dx squared, all right? You don't read it as dx squared, but you just read it as the second derivative. Third derivative with 3 marks, and then the cube, and then the fourth derivative, you start using numbers after that, after the fourth one, and so forth, all right? So now, for the first example, we're looking for find f double prime of x if f of x is equal to 2x cubed minus cosine of x plus the natural log of x minus e to the x. Now, let's first find the first derivative, right? We can't find the second one unless we find the first one. So applying the power rule, we're going to get 6x squared, and then the derivative of negative cosine would be positive sine of x. And then derivative of the natural log would be just 1 over x. And derivative of negative e to the x would be pretty much the same thing, negative e to the x. So that's our first derivative. Now let's look at our second derivative. So again, the derivative of 6x squared, that would be just 12x. The derivative of sine x would be just cosine of x plus cosine of x. And then the derivative of 1 over x, right? So again, it's not natural log of x. So remember, you write it, x to the negative 1. So that would be negative 1 over x squared, right? Take the derivative of this, you get negative 1 over x squared. And then the first derivative, the second derivative, negative e to the x, happens to be, again, the same thing, negative e to the x. And that's about it. So in example 2, let's revisit a scenario from our first week of class. Suppose a ball is dropped from the top of the height of the Burj Khalifa in Dubai, 2,717 feet from the ground. And the position equation that depicts the height is s of t in feet. The ball is from the ground at time t in seconds is modeled by the equation s of t is equal to negative 16t squared minus 10t plus 27,7t. It says compute the velocity of the ball at t equals 5. So velocity, that means we're looking for v of 5. And to find v of 5, first I have to find v of t, which would be just the derivative of that, right? So here we find derivative of s of t, position function would be v of t. So that's giving us negative 32t minus 10. And then we want to find b of 5. So that would be negative 32 times 5 minus 10. And that would give us a total of negative 170 feet per second. So this ball is dropping at a rate of negative 170 feet per second. All right, so now let's look at part B, which says compute the acceleration of the ball at t equals 5. So the acceleration would be the second derivative or the first derivative of velocity, right? Second derivative position, first derivative velocity, that would give us a of t. So to do that, we just take the derivative of this one, which we already had. So that would be v prime of t equals just negative 32, which would be our a of t. And in this case, we can say that the ball is dropping at a rate of negative 32 feet per second squared. All right. So when will the ball hit the ground? Now, when the ball will hit the ground, we're not talking about how fast it's going or how much is it accelerating when it hits the ground. Here, we're just looking for its position. So therefore, we're just looking for S of t. All right. When does it hit the ground? Is when S of t is equal to 0. All right. So all we have to do, we can just pretty much figure it out by plugging into calculators. And that's what I suggest you guys do. So your position function, right, S of t is negative 16t squared minus 10t plus 2717. You can use pretty much the quadratic formula, or you just can use your graphing calculator and find the zeros, right? And then remember that you're going to get two answers because this is a quadratic. So in this case, we're just looking for the answer, the positive answer, which is not 0. And it's going to be 12.722 seconds. All right. And then now we want to know, what will the velocity of the ball be at impact with the ground? So here we know how long it took for it to hit the ground, which is 12.722 seconds. So we can figure out the velocity of when it hit the ground at that moment. So V of 12.722, you plug it into this equation again, right? Negative 32 times that minus 10, and then you guys get negative 417.12 feet per second. So it's going pretty fast when it hit the floor. All right.